Welcome. This is the discussion over the momentum and impulse lab that we did in class. It's going to help us verify our data and analyze our data, and hopefully you get the concepts out of it that you're supposed to be getting out of the lab. Now I'm going to use the lab to verify a theorem that we know in physics that's known as the impulse momentum theory. And basically what this does is it says the impulse of an object equals the momentum. And we can actually derive an equation that we can use, or we can show this using Newton's second law. So just a quick review. Newton's second law says that the force on an object, there we go, force on an object equals the object's mass times the acceleration. So the acceleration of the object is going to equal times the mass equals the force that's on the object. Now, in this instance, let's go ahead and look at this as mass times delta V over T. So this tells me that the force equals the mass times the change in velocity over time. Now, this is just the equation for acceleration where A equals delta V over T. And using this, I can get to rearrange it a little bit to where I got force times time equals mass times delta V. And if we remember, delta V equals final velocity minus my initial velocity. Now if I distribute the mass, then I'm going to equal that force times time is going to be mass times my final velocity minus mass times my initial velocity. And here I have final minus my initial again, and mass times velocity equals momentum. So this is going to be final momentum minus initial momentum equals my impulse, or force times time. So this is the impulse momentum theorem, and we can use this to calculate how much force, or a force over a period of time, how much that will change the object's momentum. So in this case, a large force over a very short period of time will cause a large change in momentum, and also a small force over a long period of time will also cause a large change in momentum. Now, if you play sports, you'll often hear your coach, especially if it's baseball, where your coach will tell you to follow through. Now what this does is it increases this time that you're in contact with whatever object it is. So if it's baseball and you're hitting the ball and you're swinging and it tells you to follow through, it's increasing the time that the bat is in contact with the ball, which then increases the change in momentum. If you like to shoot for sport, or just shooting in general, you might know that the longer the barrel is, the farther the round will go, or the faster it will leave the bullet, leave the rifle. Now what this does is that the longer the barrel, the more force that the gas is inside the rifle, the more time that force is on the bullet, which gives the bullet a greater change in momentum. Initially it's at rest, and then over that long period of time that it's in the barrel, it's getting pushed faster and faster. Now if I look at my data here that I got from my lab, I notice that these are somewhat similar. All right? And as a matter of fact, here is the percent difference. And if I notice I'm about 6 here, I'm almost 11 there, but I'm 6 here and 6 here. So 6% difference seems to be about the average. Now what that means is it means that there's some error in my experiment. And one of that was we had to use our own eyes to select the curve. So where we were looking at testing. And so you might have selected the curve a little early, you might have selected it a little late, but just the mere fact that you had to eyeball the curve is really what gave us the most error. Also, the time that we used to calculate our impulse was given by data points, the number of data points, and then we calculated that by 0.02. Now, if those data points, if we just happen to come in right after a data point, and so we didn't count the first one, well, that's 0.02 second error. And then same thing on the back end. If we cut it off right before a data point, well, that's 0.02 seconds for the impulse on the back end, and so that's also another error. And so we could be plus or minus 0.04 seconds off on all of our times up here. Okay? So that's going to lend itself to a little bit of error. but a 6% margin on an experiment that we have in class, and being able to explain the errors of our calculations shows that this holds true. Now, it's really not that difficult to use. All you have to do is know that the impulse, or some force times a period of time, is going to be some change in momentum, V final minus V initial. Okay, and this would actually probably be the better working copy of this equation. So now all we have to do is we have to do it in the homework. This should be very simple. Just plug and chug and get the answer correct.